The right lung typically, remember there are variations, but typically the right lung has 3 lobes. You have superior lobe, you have the middle lobe, and then you have the inferior lobes. Okay? And the left lung typically has 2 lobes, superior and inferior. In the left lung, the superior and inferior lobe is divided by the oblique fissure and suboblique. Whereas in the right lung, we have 2 fissures, and one of them is our oblique fissure, and then you have transverse fissure. Okay. What else about it? There are several surfaces of the lung, and then there are also borders. One of the surfaces, which is the largest, is our costal surface, and you can see the costal impression. Then you have the mediastinal surface, and you have the diaphragmatic surface, and it's the same with the other lung. When you talk about the borders, you have its anterior border, and the anterior border is found in between the costal surface and the mediastinal surface. You have a posterior border, which is between the costal surface still, and then the mediastinal surface, and then you have the inferior border, which is in between the diaphragmatic surface, the mediastinal surface, and the costal surface. All right. Also, usually, we find that the left lung is a bit shorter. The right lung is a bit shorter than the left lung. Okay? I don't know if it's visible here, but the right is much shorter than the left. However, the right is a bit larger and heavier than the left. And that's because when it comes to the left lung, the mediastinum encroaches on some of the space for the left lung. And so we have this. The mediastinum encroaches on some of that part. So we don't have a lot of space to be occupied by the left lung. However, there's a lip of the superior lobe of the left lung, which we call the lingular lobe. It is small and thin like a tongue, and that's why it is called lingular. And this lingular lobe will reside during inspiration. It will slide into sorry, maybe that will take us back into the pleura. I went straight into the lung. Yes, but now, if you're to talk about the pleura has certain recesses. You have a costal mediastinal recess, and then you have a costal diaphragmatic recess. The costal mediastinal recess is what houses the lingular lobe. So it slides in during inspiration, and in expiration, it slides back out. All right. At this point, the most interesting parts of the lung are usually found on the mediastinal surface. And in the mediastinal surface, we have structures which we call root of the lung. So those are root structures. And when they say root of the lungs, we basically mean that every structure that enters into the hilum of the lung forms the root of the lung. So structures that make up the root include the primary bronchi, you have the pulmonary artery, you have the pulmonary veins, we have 2 pulmonary veins, you have bronchial vessels, I don't know if it will be visible here, and you have lymphatic vessels that are also running through, and you also have bronchial veins. So bronchial arteries go with the bronchial veins, pulmonary arteries, and then the main bronchi and the lymphatic channels. Those form the root of the lung. But the point at which the root structures enter into the lung, don't leave the lung, is called the hilum of the lung. So this here is our hilum, and the hilum is basically the root structures with the connective tissue in that area that help to support it. Now, we can look at the arrangement of the root structures of the lung, and it's quite a bit different between the right lung and the left lung. So in the right lung, we can start with the right. Well, let's start with the left because it's probably much straight up, and let me just modify a little here. So in the left lung, where we have only 2 lobes, a superior and an inferior lobe, we'll find that the most superior structure of the root is our pulmonary artery. It's the most superior. And then the most anterior is our pulmonary vein, which is right here. And it's a superior pulmonary vein. And then the inferior pulmonary vein is the most inferior. And this forms some sort of a triangle. Within the triangle, you have our left main bronchus. And posterior to the left main bronchus, you have the other smaller structures. And you expect to see your bronchial vessels, and I think here we can see we can see a bronchial vessel right here. So that's a bronchial vessel.
Touch it again.
So
On the left there are two.
that you can see that. Okay. So there's a bronchial vessel here, and then there's another bronchial vessel here. Okay. So we have two bronchial arteries on the left and the corresponding veins. And then the lymphatics, we cannot see them. However, you'd see some lymph nodes at the hilum, and these are our hilar lymph nodes. When you go further ahead to dissect, you'll find that, let's talk about this, then we'll come to the dissection part. When we switch over to the right, we have 3 lobes. And therefore it means that our bronchi also have to divide into 3. And that causes the major difference at the hilum. You just keep in mind that everything else is constant. The only thing that changes is that the right main bronchus divides early to give us a superior lobar bronchus. And that when the superior lobar bronchus goes up, it's going to make sure that the artery is a bit down, okay? And so we can see it right here that we have the bronchus, which is this and this. Here we can see that it's divided early. There's nothing connecting the superior bronchus, the right superior lobar bronchus with the rest. But here we can see that they're still connected. The reason it's like this is because this divides earlier, it breaks off much earlier. And so you get the superior lobar bronchus. So the right superior lobar bronchus, also called the epiarterial bronchus, which comes from epi-arterio, above the artery. And because of that, you'll find that this is our pulmonary artery. We still have our pulmonary vein, anterior most. Then you have another pulmonary vein, inferior most. And then you have the rest of the bronchus is still where it used to be. But the epiarterial bronchus is now the most superior structure. Yes. Now, in this particular specimen, we had another vein that was superior to the epiarterial bronchus. And this is a variation that exists. I don't remember the proportions, but I looked it up and I found that that's a variation. However, typically you only have 2 veins, because in the heart you also only get 2 veins. So this is our anterior vein.
We looked it up together.
Yes.
Because now in that one, they say that when they are thin like this one becomes superior, anterior, and inferior.
Yes.
Where that variation
So there are multiple variations.
But there are many other variations as well.
However, the typical thing that you expect to find is that this will remain anterior, this will remain inferior, and the superior most is going to be epiarterial bronchus, and then the lymphatic channels. Now on the right, we did not, I don't know if we did, but here you can see one bronchial artery. There's one, this side there are 2.
They look like to those guys. If you look at them, they look like they're moving 2 of them.
Okay, they usually don't move together, so it's possibly dividing. All right. And then we have the lymphatics there as well. Now, when we go further ahead to dissect, the bronchial tree together with the pulmonary arteries move together all the way to the last point of the lung, and that will be the alveoli. Now, what is interesting is that at the hilum, the arteries appear to be anterior, but as they go in, the arteries that will be accompanying the segmental bronchi and all are going to be posterior to them. So they switch over, such that the arteries are posterior, but at the hilum, the pulmonary artery is anterior. And so as we go further in, if you are to dissect this, you find that this is the epiarterial bronchus, or the superior lobar bronchus, and it divides into segmental bronchi because there are segments within each lobe. And we know from theory that the superior lobe has 3 segments, the middle lobe has 2 segments, and the inferior lobe has 5, because it's quite big, and that forms a total of 10. When you come to the left side, there are usually also 10, but the numbers are variable. In that you'd usually have 5 here, you'd have 5, but the apical and then the anterior tend to merge and they form one segment. And then also down here, 2 of the segments tend to merge. So the number is varying 8 to 10, and that's also a known variation. But as a rule, the bronchi and the pulmonary arteries, they will divide. So you're going to have, this is the left. You're going to have a left superior lobar bronchus, and then a left inferior lobar bronchus. You'll have the same for the artery. And then after the lobar ones, you go to the segmental. So you're going to have segmental bronchi according to the segments named S1, S2, S3, whatever. And then you have still segmentals down here. And conversely, you're also going to have segmental arteries. And then it breaks down all the way into the alveolus at the terminal end. The bronchial arteries, which are posterior to the bronchi, their work is mainly to nourish the connective tissue at the hilum and then the bronchial structures. Whereas the pulmonary vein is simply delivering blood for oxygenation. However, towards the deeper parts of the lungs, the bronchial arteries anastomose with the pulmonary arteries, and that helps to provide a backup of sorts. If a pulmonary vessel is occluded, the bronchial may be able to deliver some oxygenation, and if the bronchioles are occluded, the pulmonaries will still be able to do the work of the bronchioles. So there's that other distal anastomosis within it. However, when it comes to the pulmonary vein does not follow that established structure where you have the vessels moving with the bronchi. The veins will go ahead, that's why we have them paired, because you need one for the superior lobe and one for the inferior lobe. When it comes to this, we have one for the inferior lobe and then one for the superior lobe, which will give you the middle one for the middle lobe. Now those ones will move in between the segments. So they'll move in the intersegmental areas and they drain to adjacent segments. And that's the only difference with them. The pulmonary arteries and the bronchial vessels, look at the bronchial arteries nourish the connective tissue around the hilum and the connective tissue around the bronchi and the bronchial structures, whereas the pulmonary vein, like we said, it will go all the way to the alveoli. It provides nourishment to the interstitial tissue there, but also picking up oxygenation. Then what else? I don't know what else.